Apple just dropped its new M6 and M5 Ultra Max, but for local AI, the biggest surprise is a Mac Studio with up to 512 gigabytes of unified memory.
We are going to unpack one of the absolute most consequential hardware updates we have seen in years. So on August 25th, 2026, Apple dropped a massive announcement regarding their new Mac Mini and Mac Studio lineups. We are talking about the brand new M6 and the powerhouse M5 Ultra chips. And, while the mainstream tech world is buzzing about faster everyday performance, we're going to look at this through a very specific, incredibly fascinating lens: the local AI paradigm shift.
Right? It's the multi-$1,000 question. Can a Mac actually beat a top-tier NVIDIA PC at local AI? I mean, it sounds kind of counterintuitive if you've been following the AI space for a while, but here are the stakes. While ordinary users are just getting noticeably faster machines, AI developers and enthusiasts are staring down a potential revolution in how local agentic workloads operate. Apple is increasingly positioning its high-memory Macs as dedicated local AI workstations. Okay, let's dive into this and see exactly how they're pulling it off.
All right, let's jump right into part 1, the Mac hardware update.
So the architectural star of the show is definitely the M6, which is Apple's very first chip manufactured using a cutting-edge 2-nanometer process. But alongside the M6, Apple also finally unified its desktop workstation tier. This means the Mac Studio officially leaves the older generations in the dust and is now entirely centered around the incredibly powerful M5 Max and the brand new M5 Ultra. Let's talk about the Mac Mini first. It is still remarkably small, but internally, it's a completely different beast. The base M6 model starts at just $899, rocking a 12-core CPU and 12-core GPU, maxing out at 32 gigabytes of memory. Step up to the $1,699 M5 Pro version, and you're getting up to an 18-core CPU and higher memory capacities. Now, the M6 is a massive generational leap for sure. Apple claims roughly 40% higher CPU performance compared to the older M4. But for us AI enthusiasts, it's actually the internal upgrades like Wi-Fi 7 and, crucially, solid-state storage performance that is twice fast. That faster storage is absolutely vital because you need it for quickly loading those massive AI models straight into memory.
But if you want to know what truly caused a meltdown in the AI developer community during this announcement, it's this number right here: 512 gigabytes. The new flagship M5 Ultra Mac Studio can be configured with the staggering 512 gigabytes of unified memory. And this single specification basically sets up the entire central conflict of our explainer today.
So why is that such a big deal? That brings us to Section 2, the AI Memory Bottleneck, and why capacity is basically everything.
To really grasp why that 512 gigabyte number is so earth-shattering, we have to look at the fundamental physics of artificial intelligence right now. Think of a large language model as a physical object. The model's weights, the actual data that makes the AI smart, they have to fit physically somewhere in your computer's memory to run. Size literally matters here. A small 8 billion parameter model might only need 16 gigabytes of space. But when you get to the massive, incredibly capable 400 billion parameter models, those need vast amounts of physical space. We're talking up to 260 gigabytes just for the model weights alone. It's kind of like trying to parallel park an aircraft carrier. These massive models literally need a gigantic house to live in while they process your prompts, and that's before you even add extra room for the context window, the runtime overhead, and your operating system.
And that brings us to a really harsh reality check: 32 gigabytes. That is the hard physical maximum capacity of today's absolute fastest consumer PC graphics card, the NVIDIA RTX 5090. If you are building a top-tier consumer AI PC right now, your graphics card is maxing out at 32 gigabytes of VRAM. It physically cannot hold those massive 70, 200, or 400 billion parameter models in its memory. No way, no how. Which leads us to Section 3, unified memory, or basically, the Apple advantage.
This physical hardware constraint is exactly where Apple's strategy fundamentally diverges from traditional PC architecture. On a conventional NVIDIA PC, your system RAM and your GPU VRAM are totally separate islands. If you have 64 gigabytes of system RAM and a 32 gigabyte RTX 5090, you do not magically have a 96 gigabyte GPU. Your GPU is still strictly, stubbornly, limited to its 32 gigs. But Apple's unified memory pools everything together. The CPU and the GPUs share the exact same high bandwidth memory. So an M5 Ultra with 512 gigabytes of memory, it can make that entire enormous pool available directly to the GPU.
Now, to be fair, capacity is only half the story, right? Capacity dictates if a model can even fit in the first place, but memory bandwidth dictates how fast it can generate tokens, the actual text output.
The RTX 5090 is incredibly fast, pushing about 1.79 terabytes per second. The M5 Ultra is a bit slower at 1.2 terabytes per second, and the M5 Max sits at 614 gigabytes per second. So yes, the 5090 has faster memory. But remember, the M5 Ultra has potentially 16 times the high-speed capacity. It's a really fascinating trade-off between ultimate speed and ultimate size.
But, having the hardware space isn't enough. You actually need the software to exploit it. Apple knows generic PyTorch code doesn't just magically run well on Macs. So they are aggressively pushing their MLX framework. This is their own machine learning framework, heavily optimized specifically for Apple Silicon. It's designed to explicitly leverage the dedicated neural accelerators that Apple is now building directly into the GPU cores of the M5 and M6 chips. And because of MLX, incredibly popular local AI tools like LM Studio, Llama, and Llama.cpp now run beautifully on Mac hardware, making this whole ecosystem highly practical for developers.
Which sets up Section 4, Apple versus NVIDIA, a clash of hardware philosophies.
Looking at this objectively, it is an incredible contrast in engineering priorities. On one hand, NVIDIA's RTX 5090 gives you maximum raw compute performance, blisteringly fast 1.79 terabyte per second memory, and the industry-standard CUDA architecture. But you are handcuffed by that 32 gigabyte VRAM limit. On the other hand, Apple's M5 Ultra hands you this massive 512 gigabyte shared memory pool at a very respectable 1.2 terabytes per second, powered by MLX. But it completely lacks CUDA, tensor cores, and the raw computational brute force of NVIDIA.
Now, I want to be crystal clear about a very important caveat here. An M5 Ultra does not equal a 512 gigabyte NVIDIA GPU. For specific generative AI workloads, like creating images with Stable Diffusion or Flux, generating video with Minimax models, running complex comfy UI workflows, or doing heavy PyTorch training, NVIDIA remains dramatically preferable. NVIDIA retains massive advantages in specialized arithmetic, custom CUDA kernels, and deep ecosystem support for those specific visual and training tasks.
So here's your crucial rule of thumb. NVIDIA wins overwhelmingly when your AI workload fits comfortably into its 32 gigabytes of VRAM. It's just going to process it faster and with way broader software support. Apple, on the other hand, becomes exceptionally interesting and arguably wins exclusively when VRAM capacity itself is the problem. If your models simply cannot physically fit onto a 5090, Apple's high-memory machines basically step in to save the day.
Let's make this practical. Section 5, the new AI hardware tiers and how to actually choose your machine. With that rule established, how do you actually choose a setup? Well, if you are buying specifically for local AI, here is the breakdown. The new M6 Mac Mini maxes out at 32 gigabytes. It's absolutely fantastic for small coding assistants and lightweight agents. But ironically, because it's in the exact same memory class as a 5090, it's not the ultimate AI machine. For that, you actually look to the older M5 generation. The M5 Pro gets you into the 64 gigabyte class, perfect for comfortable 30 to 70 billion parameter models. The M5 Max takes you up to 128 gigabytes for running models over 100 billion parameters. And finally, the M5 Ultra up to 512 gigabytes is a specialized workstation designed for extreme workloads that consumer PCs simply cannot handle right now.
And this brilliantly illustrates a key takeaway. While the $5,499 M5 Ultra with its 512 gigs of memory is the machine stealing all the headlines, it's actually the M5 Max that most people should be looking at. Starting at $2,499, a 128 gigabyte M5 Max strikes the perfect practical balance. It offers incredible memory capacity to run multiple models simultaneously, handle very long context windows, and power complex local agent systems, all at a price that doesn't literally require a Hollywood production budget.
Apple has, whether accidentally or completely deliberately, carved out a highly unique niche that consumer NVIDIA hardware simply doesn't address right now. They've built a single-box machine capable of running enormous LLMs entirely on-device. As developers continue pushing single-box local LLMs toward 400 billion parameters, it leaves us with such a fascinating question. What do you think? Is massive compute or massive capacity the true future of personal AI? It's a hardware battle that is absolutely going to define the next decade of technology. Thank you so much for joining me on this explainer. Keep learning, and I'll see you next time.